All right, so this is Tuesday's classwork, and I'm just going to bang it out. So linear equation through -5, -7. We got to get rid of -5. X plus 5. -5 is now gone. I want -7. When I look at the change in x, -5 to 3, I know I've changed by 8 units. That's my run. -7 to 4 is up 11. So there's your statement. All right, y equals 11/8, x plus 5 minus 7. This product is equal to 14 minus 7 root 2. I'm giving you the answer first so you can pause and figure out how I got that answer just by looking at it. Okay, now I'm just going to do it. Square root of 7 times square root of 7 is 7 times 2. There's your 14. And square root of 14 could have been written as the square root of 7 times the square root of 2. So the square root of 7 times the square root of 7 is minus 7 root 2. There's your 14 minus 7 root 2. All right? Next problem. Sketching a log. I can still see the board, so you can too. Logarithms. We're going to do a mantra. How do you sketch a log? Parentheses equals 0. Parentheses equals 1. Parentheses equals the base of the logarithm, except for ln of x. ln of x, we're going to do parentheses equals 0, parentheses equals 1, parentheses equals 3, right? Because I know what the ln of 3 is. Okay, so a little bit different here. All right, so when does the parentheses equal 0? 5. That's your asymptote. It's the inverse of an exponential function. Exponential functions have horizontal asymptotes, log have vertical. You need to remember that. This is the inverse of growth, so I know it looks like that. Okay, decay would have come down this way. When does this parentheses equal 1? When I drop in a 6. 6 minus 5 is 1. We are now asking the question, what do you put on top of a 3 to get a 1? 0. 0 times 4 is 0. Lo and behold, if you do that every time, you're going to get this number. So 6 gets us -16. Okay? When does this thing equal 3? When I drop an 8. When I drop an 8 in here, then I get log base 3 of 3. It's 1. We're working with zeros and ones. 1 times 4 is 4 minus 16 is -12. So an 8 gets me a -12. And if you're looking for a pattern, when you make this the base, you get that number and this constant put together. A lot of shortcuts here after you see the process. Now, it would be nice if to see what's happening asymptotically here, I would pick a number like 5 1/9. Okay, you should explore that right now. 5 1/9 minus 5 is 1/9. What do you put on top of a 3 to get a 1/9? -2. That's why we're moving in the negative direction now, because -2 times 4 is -8, minus 16 is -24, and 5 1/9 is pretty close to x equals 5. And I could have made it 5 1/27, and that would have been a 27. And I'm going down, because these are negative exponents. Okay? And I got every problem on the board. I'll have to move the computer. That's a whole lot easier than me looking at the paper. All right? So how do I do 5 plus 5i squared? I could do parentheses times parentheses, but we're trying to see what the answer is. 5 times 5 is 25. 5 times 5 is 25. I got to double that. That's 50i. A positive squared is a positive. 5 times 5 is 25, and I squared is I squared. All right? So what's 25i squared? -25. My God, that cancels with this. This only came out to 50i. I'm kind of surprised by that result. I'm going to have to think about that one. All right, so name 3 coordinates. Well, we had it yesterday. Can you pick the critical number here? Can you pick the critical number there? Right? And if you pick those numbers, you get 0 equals 0. Well, that's true. So those are numbers that satisfy this equation. This is an equation. And these are one little part of a solution. A graph is an infinite number of solutions. Infinite number. All right, so what are we going to do? We're going to take our y's and go down 3. We'll take our x's and go up 7. You can check these numbers. You can plug 22 in, plug negative 12 in. You'll get equality. Okay? Let's see if you can see this without me having to. Yeah, I think you can. So I see cup shape down. I see I'm on the decreasing side. So 0 gets me 11. That means my x is negative. 2 into 24, 12 cut in half is negative 6. If I put negative 6 in, I'm going to put it in here this time and then change the sign. 36 times negative 2 is negative 72. So when I put these two terms together, I'm going to get positive 72 plus 11, which is 83. I now know my roots are centered at negative 6, plus or minus. To get from 83 to 0, I got to go down 83 units, and I'll divide by the a term, negative 2. Those are real roots. So if I want to bring it to the other side, I got to do x plus 6. I've got to have plus or minus the square root of negative 83 over 2, negative 2. I got to square this. This is x squared plus 6x plus 12, plus 36, excuse me, is equal to negative 83 over 2, negative 2. What's negative 2 times x squared? Negative 2x squared. What's negative 2 times 6x? Negative 24. What's negative 2 times 36? Negative 72, and then I add 83. And that looks like positive 11. By God, I'm back to where I started from. Okay, the range of this function is y values are less than or equal to 83. I got to start talking domain and range. All these y values are smaller or equal to this one. Domain, you can put anything into this equation. There's nothing preventing you from putting any number in there. So the domain is all reals. Okay? All right, 2 problems here. Yeah, we can see everything. So factoring, first rule of factoring, take out what's common. What do 6 and 12 have in common? 6. What do x and 8 next to the 6 have in common? 6 x's. Y to the 4th and y, 1 y. What do I multiply that back to get this? Looks like I need 3 y's, right? 1 and 3 make 4. And I need a couple of x's. Okay, so that gets this. What do I have to multiply this by to get this? Well, it looks like I need a negative 2. I already got the x to the 6y, so I'm done. That's the same calculation, except that's multiplication, that's subtraction. That's what it means to factor. To change addition and subtraction into multiplication. Fancy word, factor. All right, so we said the shortcut for perpendicular is minus 7 over 2, x minus t plus f. Temerity, that's a bold t, by the way, very bold t. And I don't think you can write that more succinctly. It's pretty concise right there. So where did it come from? Well, 2x minus 9 equals 7y. I won't take any shortcuts. This is 2 over 7, x minus 9 over 7 equals y. That's a constant. It has nothing to do with rate of change. Here's your rate of change. Over 7 up 2. What's the inverse of over 7? Over 2 and down 7. Right? Minus 7 over 2. There's your rise, there's your run for perpendicular. Okay? All right, now we're over here, and I am looking for an inverse. An inverse of f of x equals 2x cubed plus 5. Yeah, that's centered pretty well. Step 1, set it to y equals 2x cubed plus 5. What's the inverse? Do things to the y's, not to the x's. Now solve. So x minus 5 over 2 equals y cubed. What's the inverse of y cubed? Cube root. Let's find out if we're right. Let's put a 2 in. 2 cubed is 8 times 2, 16 plus 5, 21. A 2 in this equation gets us 21. Then down here, a 21 had better get us a 2. Let's put a 21 in. 21 minus 5, 16. 16 divided by 2, 8. What's the cube root of 8? Yay, move on. G of x equals, we want to get good at fractions. All right, so I'm going to plug in a negative 2/3. Minus 5 times negative 2/3 minus 7. Well, that's equal to 10/3. I'm going to multiply that by that number and then divide. Minus 7. Well, that's 10/3 minus 21/3. Looks like it's minus 11 over 3. Okay, now g of x equals 3/4. Well, I know what g of x is. G of x is, another name for g of x is minus 5x minus 7. So another name for g of x is minus 5x minus 7. And I want that to equal 3/4. And I don't like fractions. I wonder what could possibly get rid of division by 4. What could, oh, multiplication, everything by 4. Oh, that's minus 20x. That's minus 28 equals, oh, these 4's cancel, equals 3. I'm going to put my 20x on this side. I don't like dividing by a negative. I'm going to bring that this way. Minus 31, I like this division. Minus 31 over 20 equals x. Yep. So minus 5x minus 7, just for the record, has an intercept of minus 7. It's going down pretty steeply at 5 to 1. 3/4 is here. 3/4 is right about there. And that does look like I'm near the origin, but it's negative. So that x right there is where that point of intersection occurs. Ah, I want to find out when one function equals another function. I got to solve something. I got to solve x to the 4th equals x squared. Well, bring your x's to the same side. That's a rule for solving equations. I don't think I've said that one yet this term. You got to get your x's together. I don't see any way to do this with inverse operations. Inverse operations takes care of about 90% of the equations you have to solve. And the next 7% you do by factoring, writing as a product. How do I write something as a product? I take out what's common. X squared times x squared minus 1 equals 0. I recognize the difference of two squares. X squared times x minus 1 times x plus 1. I think I can see my critical numbers now. I think 0 gets the job done. I think 1 gets the job done. I think negative 1 gets the job done. Okay, I kind of lost you on that one. Okay, I think 0 gets the job done, 1 and negative 1. Put any of those numbers in and you got yourself a 0. Yeah. X to the 4th, by the way, is slowly going through the point 1, 1, where x squared does it quicker, but then less quickly. So that's what your graphs look like. That's x to the 4th. That's x squared. That's at negative 1 it intersects, at 0 it intersects, and a positive 1. All right? Because if you put a half in, a half times a half times a half times a half is a smaller number than a half times a half. Okay. Okay, what am I doing? I'm sketching. I guess I'm sketching. Is that what I'm doing? Am I doing an inverse? No, I'm doing inverse over there. Looks like I'm sketching this. So exponential growth is based on a constant. Anybody see the constant over here? I don't see the constant. I guess it must be 0. All right, so what am I doing here? I guess I'm just sketching. I hope I'm just sketching. So what are we going to make the parentheses, not the exponent? A 0 and a 1. I know what 3 to the 0 is. So what makes that thing 0? 20, 20. So 20, 20, and I'm on top of 0. You know what? I think I'm going up 5 units. And then if I make this a 1, I think I'm going up 15 units. So what makes that a 1? Oh, I guess I got to change 2020 by 7 years. 2027 gets me 15 on top of 0. Okay, let's plug it in and see. 2027 minus 2020, 7 divided by 7, 1. 3 to the 1 is 3 times 5. Yeah, that's 15. So there's your graph. Okay, and I wanted 2020 to get me 5 because 3 to the 0 is 1 and 1 times 5 is a jump of 5. Okay, that's how you graph that. What's the inverse of this critter? Well, the inverse is to change g of x to y equals. And then you're going to change your x's, your y's to x's and your x's to y's. The first thing you're going to do is divide by 5. And then the next thing is to undo 3 to the. I wonder what the inverse of 3 to the is. Well, the inverse of e to the is ln of. I got a feeling the inverse of 3 to the is log base 3 or log base 3 of. So I have to do log base 3 of that. I'm going to come back to this here because I'm going to put some numbers in a minute. I'm butchering this thing. All right, I've made my case here. So now that moves this to the other side. Division by 7, multiplication by 7, subtraction of 2020, addition of 2020. Okay, so we had 5, 3 to the x minus 2020 over 7. And we said 2020 got us 5. Then down here, 5 better get you 2020. Let's put a 5 in. 5 divided by 5 is 1. What do you put on top of 3 to get a 1? A 0. What's 0 times 7? 0. I get 2020. Huh, that was the inverse. 4x squared minus 36x, I guess we're doing a product. Good, I don't know. All right, I suppose it's just a product. So I'm just going to pull the 4x out because it's common, and I'm going to multiply x minus 9. I don't know. Maybe I asked something else. Y equals x cubed was your answer to the graph, the table values. You go look at your x's, cube them, see what you get. So 2x squared plus 32 equals 0. So we're going to move the 32 to the other side. It's gone. We're going to divide by 2. It's gone. So x squared equals 16. If you say x equals 4, you get no credit because you could have said plus or minus 4. You got to remember the plus minus. What is x squared? X squared is a parabola. When's it hit a height of 16? Well, I got news for you. There's a negative side to that. And if you forget to put the negative side down, you don't own it yet. And I want you to have ownership. Now, years ago, I used to sneak up. I'd give people 2 weeks to learn that. Then I'd sneak up behind them. And while they're writing like this, with their back to the board, they forget the plus minus, I would yell at the top of my lungs, "What?" Unfortunately, I did it to a poor fellow that had a concussion the last time I did it. But it was very effective in getting kids to learn. Oh, y equals 2x squared minus 8x. I better get the sheet up. This one here first. So what's the y-intercept? Well, anytime you want a y-intercept, you plug 0 in. So that becomes 0 plus 2 times 0 plus 3 plus 4. I think 2 times 3 is 6 plus 4 is 10. That goes through 0, 10. Yep. 2x squared minus 8x. I guess maybe we're sketching it. I don't know. God, I better get the sheet. I can't remember what I did with this. You know, if I was going to sketch this, I'd probably put it in factored form. I'd probably take a 2x out times x minus 4. That gives me 0 and 4 as roots. 0 and 4 as roots. And I know it's cup shape up. What's between 0 and 4? 2. So if I put a 0 in, I know it goes through the origin. And if I put a 2 in, I get 8 minus 16. That's the nice 2-to-1 ratio we're looking at. So minus 8. But I honestly don't know what I even asked. All right. Sorry about that. All right. Log base 25 or 1/5. Got to get the same base. 25 is 5 squared. 5 squared to the what? Equals 5 to the negative 1. That's what 1/5 is. So 2x equals negative 1. X has to equal minus 1/2. Do you have a sense of what that operation is? It's taking the reciprocal of a square root. What's the reciprocal? What's the square root of 25? 5. What's the reciprocal of 5? 1/5. Okay, that's square root. That means reciprocate. So if I have 25 to the minus 1/2, that's the square root of 25, which is over 1, and then I reciprocate 1/5. 16 to the negative 1/4. This is the 4th root of 16. 2 times 2 times 2 times 2 is 16. So what's the 4th root of 16? 2 to the negative 1. What's 2 to the negative 1? 1/2. Number 22, I don't have it in front of me, but I think I remember. I think you were going to triple 50 or double 50 pounds of effacement every 30 years. Well, if you're going to double something, you got to start with what you're going to double, which is 50. And if you're going to double it, it's an exponential function, right? And if I want to double 50, then I want 50, and then I want 100. Well, how do I double 50? I do it one time. But this is the number 30. I want it to act like the number 1. Divide by 30. Okay? If this is 0, 2 to the 0 is 1. Right? And 1 times 50 is 50. And when you put a 30 in, 30 divided by 30 is the number 1. 2 to the 1, 2 times 50, 100. Okay, 60 is going to get me 200. 90 is going to get me 400, so on and so forth. I have a lot of knowledge. Solving an absolute value, we're going to use the branches. What is that branch? That branch coming down is minus 2. X minus 3 minus 4 equals 30. What's that branch right there? That branch is positive 2. X minus 3 minus 4 equals 30. Okay, so this was the vertex 3, 4. If I put a 0 in, I get 6 minus 4 is 2. Oh, wait a minute, I can't, I got to put it into the original. Yeah, here's the original. Put a 0 in, I get 6. Oh, this is negative 4. Okay. I knew something was wrong. So if I put a 0 in, 6 minus 4 is a height of 2. So this is a height of 2. We're looking for a height of 30, way up here. Okay? And we know that a 0 gets you 2. Okay? So 3 units got me 6. I got to go another, I don't want to talk about it. Let's just solve it. So 34, divide by negative 2, negative 17, add 3, negative 14. That's the intersection over here on the decreasing side. On the increasing side, add 4, move bottle, divide by 2, add 3, 20. 20 is on this side. Yep. And what did we say the other side was? Negative 14. Could anybody do 20 minus 14 divided by 2? Oh yeah, right in the middle, 3. Going in the next room. Here we go. Don't die on me, battery. All right, so I guess I want to see if you can see from here. Boobity, boobity. Yeah, you can see. So you always want to check to see if you can factor something first. Plus 7 equals 0. Okay, so 7 and 1 add up to 8. So x plus 7, x plus 1, 0. So we got our answers. Negative 7, negative 1. Okay? I'm just going to really fly through this now. The old man's tired. 6:15, roughly 6:15. I'm still in the science room. All right. So we're going to graph. We're going to solve. All right. To solve this, multiplication by 1/4 is the same as division by 1/4 on the other side. How do you divide by a fourth? You multiply by 4 over 1. What is 4 over 1? Times 1/2. What's a half of 4? 2. So now we're here, right? What's the inverse of log base 4 of? 4 to the. So the inverse of a log is to write it exponentially, right? The inverse of log base 5 of 25 gets you 2 is 25 equals 5 to the 2. All right, so all you're going to do is move the base to the other side under the exponent. So I'm going to move this under the exponent. And I have done the inverse of that thought process. So x minus 3 equals 16. Looks like x is 19. You can plug it in and check. It'll work, I hope. It's getting late. All right, so this is really trying to move you towards understanding synthetic division, where it comes from, where long division comes from, right, is this process. And we might do some long division later, but we're certainly not going to do synthetic division. It's archaic, right? So I got the marker. I can make this work. X times x, x squared. I'm well on my way. I have now created negative 3x. Think of the number negative 3 because you want to get to negative 5. How are you going to get from negative 3 to negative 5? You're going down 2 more. And there's your minus 2x right there. Okay, but that gives me negative 3 times negative 2. That's positive 6. I don't want a constant of 6. I want a constant of negative 9. How do I get from 6 to negative 9? Down 15 over x minus 3. Okay, how do I know if this is right? What's the critical number for the factor x minus 3? 3. Let me put a 3 in over here. 3, 9 minus 15 minus 9. Oh, it looks like minus 9, positive 9, cancel, minus 15. Must be a coincidence. Must be a coincidence. All right, what's next? 4i to the 25. Can we see this without me moving the computer? Bad legs now. All right, so we're going to rewrite that as 4i squared. How many times will that fit into 25? I think 12. That gets me to 24. I need one more. All right, so that's 4 times -1 to an even number times I. I think -1 times -1 is an even, and that's +1. So this is 4 times 1 times I. My final answer is 4i. That's simpler. All right, what am I doing here? Slope-intercept form, I haven't done that yet, so that's probably what I'm doing. So minus 2/3 x, minus times a minus is a positive. 2 times 5 is 10, and then I'm dividing by 3. I want to have the number -2 expressed in thirds. I think it's 6. Yes, I think 3 times 2 gets me the numerator here, 3 times -2. So minus 2/3, x, 10 minus 6 is positive 4/3. And I'm doing this because I want you to have a fractional practice. Did I do that so you could see it? That's sort of. Yeah, it's all captured. All right, so next problem. We've got 3 problems coming your way. Hopefully you can see it from here. All right, 3 problems coming your way. First factor. Well, the only thing I know about this, if I'm writing it as a product, is it's got to be 1 times 5. I really don't know if I got a 1 and a 6 working together or a 2 and a 3 until I start playing. So let me start with 6 times 5, 30. I'm nowhere in the ballpark. I'm not going to put a 6 here. 1 times 5 is 5. The 6 has to go here. 5 and 6, that's out the window. Okay, so it looks like I'm going to do, 2x. 2x times 5 is 10, and 10 and 3, where the heck am I? 3x here. There we go. Usually you're doing the constants, not those. All right, so it threw me for a second, and I want a negative. So that's negative because that's a bigger product than that. All right, so did you notice how I did trial and error? And the more you do it, the better you get. Okay, so you struggle with it. All right, so how do I do the inverse of log base 5 of? 5 to the. Remember, we just said slide it over. Slide it over, and then this is gone. So x is 5 to the -2, which is 1 over 25. Let's go back and plug that in. What is the exponent that you put on 5 to get 1 over 25? Yes, it's -2. Okay, so let's solve this. -4 goes to the other side. -14, boom, you're gone. Multiplication becomes division. Boom, you're gone. Square rooting becomes what? Oh, I hope you didn't forget the plus minus. I might have to go back to sneaking up behind you. It's gone. What's addition of 3? Subtraction of 3. There's your roots to that quadratic. There's our roots. We could go backwards, end up with the equation. Can you see this? All right, the trick here is to look at the x column. 0, 1, 4, 9, 16. What kinds of numbers are those? Where'd they come from? Squaring something, right? Those came from squaring something. So, well, we're not going to square these numbers, but what could we do to make them maybe some operation that you would perform on these? If you said square rooting, you'd be right. So if you take the square root of 0, you get 0. That's a good one. Square root of 1 is 1. It becomes -2. So let's try -2 times the square root of x. Square root of 4 is 2. 2 times -2 is -4. You know what? We're getting this. I'm starting to get that. Okay, so that's what it was. So I'm out of order here, but x equals 3 plus 5i. So x minus 3 equals plus, should be plus or minus 5i, but my Google whatever template math, the program I'm using doesn't do it. Now I haven't done this line of work in class because we got, there's really no need, but I'll show it right now. What does that come from? What does plus or minus 5 come from? It comes from plus or minus the square root of -25. That's why we're squaring now. Okay, I should have done that initially. I did. So I'm squaring both sides. So x squared minus 6x plus 9 is equal to -25. All you got to do is add that to this side. And you get x squared minus 6x plus 34. Okay, we're getting there. We're getting there. Then I'll upload this. Now I got to find out Google Calendar for math help. I have no idea how to find that or where, but I'll try. All right, so what do we have here? All right, quadratic, so we know we got the x plus 1 squared plus 7 because of the shape of the curve of the graph. So I know I've got acceleration on both sides, squaring a positive and a negative. Positive or negative squaring, same outcome. Okay, so now the question is, really, this is quadratic change. And so if I go from -1 over to 5, what kind of quadratic change do I get? What kind of rectangular change do I get? 36 units of area. That's what I get when I drop a 5 in here. 36 plus 7. Well, 36 plus 7 doesn't get me 24, so I'm not going to do 36 plus 7. I'm going to do 17 plus 7. Okay? That's going to get that graph. All right. I did this one at the beginning of class. Maybe you still do it. You know, it's 45 minutes later, you're trying it again. Difference of cubes. You work with the cube roots. In this case, we worked with 3 minus 2. And then what do you do over here? You square the first number. You take the product, -6, and you change it to +6. You square the last term. 3 minus 2 is 1. 15 plus 4, 19. Guess what 27 minus 8 is? 19. But instead of showing it as a difference, I am now showing it as a product. All right, this one here, that's a difference of 2 squares. That's 6a plus 5m times 6a minus 5m. No middle terms. But I end up squaring, right? Squaring that gets me that. Squaring, well, I'm not squaring, I'm doing plus minus squaring. I'm doing 5m times minus, changing the sign. Anyway, 5 times 5, 25m squared. All right, 6, 8, 11, 9. That's absolutely meaningless to me. What was I asking you to do? 6, 8, 11, 9. I have no idea. Maybe I'll do it at the beginning of class because I'm not helping you right now. Hopefully we'll get to that one. All right. Yep. You know, I'm trying to get out of here so I can go to math help at 7. So I'm rushing things again. That's why fire trucks are red, because reds are Russian and Russians are reds. I don't know if I have any Russian students. All right. The trigonometry is strictly for the students I've had before, because I'm trying to create some tutors in the room when we get to trig next week. All right. Cosine of 11 pi over 4. So pi is the top half of the circle. We cut it up into 4 parts. We draw the triangle. We're doing 11 of them, right? So there's 8, 9, 10, 11 is here. And I'm looking for cosine. Do you remember what that width is? -√2 over 2. Okay. Where's the cosine equal? √3 over 2. Cosine is width. That's at your 60-degree. I wanted width. Sorry. I did height. Width of the triangles in the unit circle. So I'm here and I'm here. What's that? Pi over 6. What's this one? 11 pi over 6. Okay. Those of you who haven't had any trig yet, don't worry about it. We're going to break this down for you later. Plugging in pi over 6. What's 2 times pi over 6? Pi over 3. What's pi over 3? You're thinking 60 degrees. What's the 60-degree width? 1/2. 1/2 of 40, 20 plus 10, 30. Sine of 5 pi over 6. I'm breaking pi up into 6 parts. 1, 2, 3, 4. We're over here. We drop down the perpendicular. What's that altitude? 1/2. Hopefully that brings back some memories. All right. That was for the kids I've had before. The students, excuse me. Shouldn't be saying kids, but I'm getting up there in age. All right. So we're going to look at x squared minus 6 equals x pictorially first. I know you're all going to go after it numerically. Even though I asked you to do it pictorially, show the graphical solution, I got to sit down. You don't hit to bother me. Okay, so can I see where I'm working? Yes. So we're going to graph y equals x. There it is. Now we're going to graph x squared minus 6, which is just a parabola dropped down 6 units. This is 0, -6. And we're going to estimate, and this is y equals x, and that root is what? Square root of 6? -√6? And this is going to be positive root 6. Okay, when does that equal to 0? So I know this intersection is less than the square root of 6 on the negative side. And I know this intersection is more than the square root of 6. So now we go and we solve it. So how do we solve it? X squared minus x minus 6 equals 0. Well, that's factorable. That's x minus 3 times x plus 2 is negative 2. Is that number to the left of negative 2? Yes. So that's negative 2 right there. That's intersection. And this one is positive 3. Is 3 bigger than the square root of 6? Yeah, it's right where it belongs. Okay, so that's how you do that one. Now we're going to do a log again. Oh, we got to graph a log. How do you graph logarithms? How do I graph 4 log base 5, x minus 5, minus 16? I'm going to make that 0. That's x equals 5. That's the asymptote. How do I make that 1? Because that's going to get me negative 16 by picking a 6. What do you put on top of a 5 to get a 1? 0. 0 times 4? Oh, yeah, negative 16. So 6 gets me negative 16. Then I want to get the base. Well, I better put a 10 in. Better put a 10 in. Now, this is 1 unit of change, by the way, from 5 to 6. So I got myself a ruler. That distance is a distance of 1. So 10 minus 5 is 5. What do you put on top of 5? You get a 5, a 1. 4 minus 16, negative 12. So 10 units is from 6. I got to go another 4, right about here. And I'm right about there. So 10 gets me negative 12. I want a height of negative 8. Negative 8 is further up, right? Negative 8 is going to be somewhere like, can you see this? Out here, because this is slow growth, right? So to get to negative 8, I'm anticipating a pretty big x. You know, pretty big x. I went up by 4 here, and that went up by 4 units. Certainly not linear, but it's starting to look that way. Well, let's find out what it is. Let's actually solve the problem for negative 8. What's the first step? I got to bring the 16 over. So that's positive 8, right? No, yeah, 16 minus 8, positive 8. This is gone. I got to divide by 4. Well, that's 2. That's gone. I got to put the base under the exponent. That's gone. I got to add 5. Boy, 30. It's out there. All right, so that's good. I don't usually see people doing well on these problems for a while, but it gets there. So we got minus 3, x minus 4, minus 1 as a graph at left side of the equation. That's V-shaped down. I know 4 gets me negative 1. And if I put a 0 in, I'm on this side. I usually put it right in the middle. 0 gets me negative 3 times 4, negative 12, minus 13. Yeah, that's minus 13. That's an ugly minus 13. I'm just going to give you the height. Yeah, 0 minus 13. And we want a height of minus 10. Minus 10 is above it. That's a height of minus 10. I can see that I have an answer between 0 and 4. When I solve this, if I don't get an answer between 0 and 4, I'm going to be very upset. This is the increasing branch, which means I'm going to do positive 3, x minus 4, minus 1 equals negative 10. I'm going to add 1, negative 9. I'm going to divide by 3, negative 3. I'm going to add 4, negative 1. I don't like the positive 1, thank God. I add 4. Is the number 1 between 0 and 4? Absolutely. Okay, so that means I'm, do I want to do this side? Well, might as well. So that's going to be the decreasing branch. So we're going to do minus 3 and go through the steps again. So I'm going to add 1, minus 9. I'm going to divide by negative 3, positive 3. I'm going to add 4, 7. So this side, a 7 gets me negative 10. On this side, a 1 gets me a negative 10. What's 1 plus 7? 8 divided by 2, 4. There's the symmetry. I trust those answers. Last problem, thank God. All right, so I'm going to graph 3, 2, x minus 5 over 4. I'm going to make this thing 0 and 1 in a minute. Plus 1. Exponential growth. A doubling. My first jump is 3. I'm on top of 1. And I am doubling a 3. And that's going to get me 6. All right, so let's put our x's in. Looks like I want a 5. Because that makes a 0. Anything to the 0 is 1. I get 3 and 1. 3 and 1. 4. And then I'm going to pick 4 times 1 is 4 plus 5 is 9. I'm going to pick 9. That gets me 2 to the 1. 2 times 3 is 6 on top of 1. That gets me 7. Provided I pick the right number. Okay? Now I want to know when this thing equals 25. Well, that's 4, that's 7. 25 is way up here. Woo! Way up there. What do you think? 5, 9, almost feels like 13. Almost feels like, you know, from here to here, got me to that. Well, doubling. Well, let's find out. Let's actually solve the equation. All right. What's the first thing you're going to do? Move the 1 to the other side. Now it's 24. What are you going to do next? You're going to divide by 3. Now it's 8. What's the inverse of 2 to the? Log base 2 of. We're trying to find the value of an exponent here. Logarithms are exponents. What's the exponent you put on top of a 2 to get an 8? I think it's a 3. 3 times 4, 12 plus 5, 17. Remember we were at 9 and we said it's to the right? 17. Okay, now I got to upload this thing before math starts. So I'm just going to go to the loop. All right, and this is your worksheet for tomorrow. And then you do it again at night. Toodaloo.